No.
Hello, Mr. Ryan, right? Okay, so last lesson we talked about this problem, right? We given an integer and we want to split it into two integers. Obviously, this is the non-negative integers. And both integers can have these leading zeros. And we want to find out the minimum sum, right? And the strategy we taken is greedy, right? So we saw the digit and then we try to pick the digit from the smaller one to the bigger one. Right? Because we want to leave the larger digit to the right hand side, right?
Yeah.
Okay. So look, this is the strategy. We sorted the digit. Yeah, we converted the integer to a string. We break it down into an array of the digit characters and we sort it. This is the sorted array. And then we use the least comprehensions to pick every other digit. The first number, we start picking every other digit from the first digit. The second number, we start picking every other digit from the second digit. So you will pick the second, the fourth, the sixth, right? And etc. When we pick the digit, it's a list. We join it to a string. And then we need to convert it back to an integer. And then we add it up, right? The time complexity is O and again if n is the number of digits. Okay. The key thing here is that we sort it, right? We have learned quite a few sorting algorithms, right? The quick sort, the merge sort, bubble sorting, selection sort, insertion sort, right? And we also mentioned about the bucket sort.
We sort by using buckets.
That's right. Basically, like buckets, each bucket is a counter to count the number of digits, right? Given this, in decimal, how many different types of digits we have? Given 10, yes, 10 from 0 to 9, right? Any number can be represented by these 10 digits, right? So we can just count, right? For example, we can count using these buckets. So how do we count using the bucket? Look, so just imagine how many buckets you created at the beginning.
10.
Yeah, so 10 buckets, right? Each bucket for each digit, right? So look, a bucket, right? I'm just going to draw a simple version of it, okay? Okay, so 10 buckets, right? 4, 6. Is it 10 buckets?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
Okay, so this is
1, 2,
0, 1, bless you, 3, okay? Okay, so etc. Okay, so let's consider this number 2, 3, 1, 4, 4, 7. Okay, this number, right? So 2 falls into this second bucket, right? 0, 1, 2 is the third bucket, so this is 1 here. 3, 1, 1 here, 4 here, 4. Okay, another 4. So we increment this counter to 2, right? And 7 here, okay? Right? So now we have 10 buckets. Each bucket is a counter, right? So okay, so just imagine, okay, now all the rest is 0. How do we construct these S1, S2 two numbers? How do we do it? Right? We just go through these digits and then we count how many times they appear, right? Yeah, make sense? Okay, so how do we construct these digits? So obviously, we need to check from left to the right, right? The left is 0. This is the smallest number, right? Look here, S1, S2. Now I have 1 0 here. So where does it go? Here, right? 0. 0, nothing. 1, where does it go? I have 1, 2. 2, for digit 2, I have 1. Where does it go? Here, right? And move next. Where does it go? The 3. Yeah? Okay, move next. 4, I have 2. Okay? 4 here, right? Because I have 2. 0, 0, 0. Now this 7, where do I put it? Here, right? Okay, so the minimum sum.
Why is there 2 in the second? There is 2, 3,
Okay, so where is it 0? So this is a mistake.
Yeah, there isn't any 0 in the number.
2, 3, 1. Okay, so actually it's here. Yeah. Sorry. So this 1 should be here, right? Okay?
Yeah.
So what's the sum? Yeah, is this the minimum? 1, 2, 3, 4, 4, 7. It's the same, right? It's the same as sorting, right? 1, 2, 3, 4, 4, 7. So 1, 2, 3, 4, 4, 7. Yeah. Okay. So this is basically the same as sorting, but we use the bucket sort because we know there are 10 different digits, and then we just count how many of them. But when we count it, we can pick the numbers from the left hand side to the right hand side. So we are now dealing with the number 0. We are now dealing number 1, number 2, number 3, number 4. If they are more than 1, we can just keep doing that. Am I right? Does it make sense? Yeah? Okay, let me try another example, okay? Just to make sure you fully understand. And then we can do the coding, okay? So, try another number, right? 4, 4, 3, 2, 2, 7, 7, 6. Okay, then how many numbers? A number. Let's make it another 0 here. So 10 buckets, right? Okay, this is 10 bucket. 4, 4, make it 2, right? 3, 1, 2, 1, 2, make it 2, right?
Yeah, that's 1, not 2. That's bucket 1, not 2.
Okay, so yeah, that was a mistake. Yeah, you were listening. Yeah, that was testing. Okay, good job. 7, 6, 0. Yeah. So what are the rest? What should I put here? 0. Okay, good. Okay. Now, okay, so now S1, S2. We have 1 zeros. So where should I put it?
On the number.
Yeah, S1, yeah, 0, okay? Okay, now move it. What do we do with it?
Nothing, because
Skip, yeah, okay. Now what do we do?
give it to the other number,
Okay, and?
and then give it to the first number.
Yeah, and?
1.
Move where? Because 2, right? And what's next?
Put 3 in the second string.
And?
Move. Put 4 in the first string and then put 4 in the second string.
Yeah.
Then move and then skip that and then and then put 6 in the first ring and then move on and then put 7 in the second string and the first string and then skip the rest.
Okay, so this is the number. Yeah, got it? Does it make sense?
0, 2, 2, 3, 4, 4, 6, 7.
Yeah, so it's basically this number plus this number, right? Okay?
Mm-hmm.
Why can we do it? Why this approach is okay? Can you just say, okay, why this is gives the optimum, the minimum?
Because they're different place values, and you can put digits in different place values. Because like there's in the ones column, tens column. Like if you put like a 1 in the ones column, it will be 1. But if you put ones in like 1,000 column, it will be 1,000. So it'll be more. So you want to get the smallest. So you put the smallest number in the bigger values and the bigger numbers in the smaller values, so they'll value less.
Good job, yeah, that's basically it, yeah. So basically we are sorting, yeah? It's the same as sorting, right? So last time when we sorted, we just sorted, right? What do we get? 0, 2, 2, 3, 4, 4, 6, 7, 7, right? And then we pick the number from left to the right, right? And this is the same thing, right? So we just count it. We have these 10 buckets because there are only 10 possible digits. And we just count how many times they appear. It's like a bucket, right? If you have one more 2, you just increment the counter at 2. And then we try from the left to the right, because the left, this is the 0, the smallest. Right? 0, 1, 2, this is in the sorted order. And if it's 0, if the counter is 0, we just skip it. This is basically the same thing, but obviously this is the sorting, this is the faster. Why is it faster? Because we only have 10 buckets. If there are n digits here, we just go through this n times, and then we have all the digits in place. Right? But for the sorting, if the regular sorting, quick sort, the time complexity is O and log n, right? And then if we use the bucket sorting, look, what's the time complexity? What's the time complexity? O n, right? Which one is better? This one is better, right? Because they have 10 buckets, we just go through once. Okay? Okay, so yeah, that's a strategy. But writing this in code may not be elegant as the first approach. Remember, the first approach is just 3 lines of code, right? But for this one, it takes more than 3 lines of code, and it's not as elegant as the first approach. A bucket equals, at the beginning, 10 buckets of zeros, right? And then we go through this, right? For I in this n, strn, converted to string, this I, and then b, integer, I, converted back to the index, the values, plus equals 1, right? This is bucket. We are incrementing we are putting the numbers in a bucket, right? This is a bucket, and we go through the digits, and we're putting the digit I to the bucket. Okay, and once we have that, then we can start S1 equals 0, S2 equals 0, right? And Y I equals 0, Y I smaller than 10. Right? First of all, we need to skip the bucket which is 0. So how do we skip the bucket which is 0? Y I smaller than 10 and Si is actually Bi is actually 0, then I plus equal 1, right? So we skip the empty buckets, and then we need to take the numbers, right? We need to take the numbers. So how do we take a number? S1 equals S1 times 10 plus, now this is the bucket, we are now at bucket I, so bucket I. Now, once we take the one bucket, what should we do with it? We need to decrement the counter, right? Look, there are 2 4s. I take 1 4 already, so I need to decrement it to 1, right? So now I take this I, and I need to decrement it, which is Bi minus equal 1. So once we take this bucket, then we need to check if there are more digits for the next number, right? So we need to, obviously, we need to keep skipping this digit, right? And Bi, if it's 0, then still I plus equal 1. And if I is already at the 10, if we are using up all the digits, then we just break. Otherwise, S2 equal S2 times 10 plus I, and Bi minus equal 1, okay? And then at the end, return S1 plus S2. Okay, so look at this is not very elegant, right? Because there's some special case we have to make here. But the strategy, the point is that we take a digit, we always take a digit in turn, right? In turn. And then we move the counter I. Move this I to the right until it reaches the 10. For example, the S1 is 0 to 4, right? So if I take the digit 6, what does the S1 become? Now S1 is 24. So if I take the one more digit and put it on the right, what does the S1 become? 246, right? So how do we get 246 from 24? 24 times 10 and put the 6 on the right. That's basically it, right? So we multiply the number, current value times 10, means that, okay, this is the number I have. I multiply by 10.
Like shifting it.
Yeah, I squeeze one location for the new digit, right? This is 24. So 24 becomes 240 plus this. This is where it is. We're done. So we take the number, take the bucket I, and then we need to decrement it, right? Decrement it, and then we move to the right. Okay? Bless you. Okay, that's it. What have you learned today?
We learned about what we learned last time we coded on Monday about find splitting number and add them up together, find the meaning, and today we're using bucket sort.
Okay, so what is bucket sorting?
Bucket sorting is basically using buckets or counters.
Yes, okay.
And then you lay them out and get the numbers and put them in the right buttons and do right how much, and then you go through them and then just put them in string 1, string 2, and keep on going by.
Yeah, the bucket sorting is useful if we know the number, the data type is limited. For example, in this case, there are only 10 digits, right? So we can go through it once and put it in different buckets. But if the data is lots of the different contents, you can't always have unlimited buckets, alright?
Mm-hmm.
Make sense? If you have unlimited buckets, the performance will be not as efficient as these limited buckets. Make sense? Eric, any comments?
No.
Okay, that's it for today. Bye bye.
Bye.
Bye bye.